My name is Eric Scott, and this is my submission for Lab 7. So this is a quick rundown of what I did for the first exercise. I knew that no current could run into the inverting input terminal, so then I can set the currents across R1 and R2 equal to each other. And then I simplified that equation and solved for V out. Then I know that V minus equals V plus, and V plus is just the input voltage because there's nothing between the two except a wire. So then I plug the input voltage into V minus and simplify that equation and divide the output voltage by the input voltage to find that the gain is R2 over R1 plus 1. This is a brief look at the Arduino code that I created. So I created 3 integers, V in, V minus, and V out. I set them all to 0. I used them later. And then I set the baud rate. And in the loop function, I read in values from the 3 analog pins for V in, V out, and V minus. I then print them to the serial monitor separated by a tab character and wait 50 milliseconds. So this is a quick look at my circuit for exercise 2. The output voltage from the potentiometer runs into V minus for the op amp. And this is what it looks like in processing. You can see as you change the input voltage, the output voltage follows accordingly. The output voltage is actually covered up by this yellow line, but they're identical in this case because it's a unity gain amplifier, and it follows it until the input voltage goes below 2 volts, and it also plateaus slightly below the input voltage once you reach 5 volts. For exercise 3, all I changed in the Arduino code was I added another integer to store the voltage of the inverting input terminal, and then I read that voltage and output it the same as the other ones. In the processing code, I add another integer in the same way, and the process is identical to the other ones, and this is what it looks like in the processing window. You can see V plus is always at 2.5 volts. The white line, the input voltage, goes off the screen downwards, but that switches between 2.5 volts and negative 2.5 volts, and the output voltage follows it accordingly. This is my circuit for the third exercise. This right here is the voltage divider to get 2.5 volts. And then the 2 resistors that are included in the circuit, and everything else stayed relatively the same. So this is a quick derivation for the output voltage for the fourth exercise. So I know that the V plus equals 0 because it's connected to ground. That means V minus is equal to 0. So then I can equate the currents as the current across the resistor has to equal the current through the capacitor. And then I just solve that for V out and find it's equal to the negative input voltage divided by the resistance times the impedance. This is my circuit for that exercise. You can see I still have this 2.5 voltage divider. Then this is the 4.7 kilo ohm resistor, and the capacitor connects V minus to the output voltage. And this is just a look at what the output looks like in processing as you change the input voltage.